Hello again, method students. In this section, we're going to have a look at a rule called the product rule, which is what we use to differentiate functions whenever we have a function that can be written as two functions of x multiplied together. Okay, so if we have a look at this rule, and it can be written in a couple of different ways. Firstly, the rule written in function notation. So this says if f of x equals u of x times v of x, right? So we've got two functions of x multiplied together. Then f dash of x, so then the derivative will equal u of x, so the first function as it was, times v dash of x, so u of x times the derivative of v of x, plus that same thing but the other way around, v of x times u dash of x. Okay, if we use some slightly different notation, if we said that if y was equal to u times v, then dy dx would be equal to u times dv dx plus v times du dx. I actually think the product rule, as much as these rules, these formulas are helpful, the product rule is best remembered in words. At least that's how I've always done it. So the way you kind of think of it is that the derivative will be, well, you write down the first bit times the derivative of the second bit, plus you write down the second bit times the derivative of the first bit. And that's basically an informal way of remembering what these two formal equations are telling you. So let's get stuck into some examples and hopefully you'll get the hang of how this works. Remember that you're only ever using the product rule though when you can see that the original function is the product of two separate functions. So in example 22 here, we've got f of x equals 2x plus 1 times 5x cubed plus 16. And you can see that each of those two parts on its own would still be a function, right? The function f of x equals 2x plus 1, that is a function. And if it was f of x equals 5x cubed plus 16, that would be a function on its own as well. And they're being multiplied together. So our product rule says, if we want to work out the derivative, we write down the first part as it is, write down the first function as it is, so 2x plus 1 times the derivative of the second part, which is the derivative of 5x cubed plus 16, and that derivative is just 15x squared, plus the second thing as it is on its own, so 5x cubed plus 16, times the derivative of the first function, which in this case is 2. The derivative of 2x plus 1 is just 2. Okay, and that's applying the product rule. And then you write things in as neat sort of way as you possibly can. And depending on the question, you might have to rearrange things and get the expression into a certain form. But if you're not told that, if all you're told is to find the derivative like we are in this question, then that's as far as you would need to go, right? No need to expand it out and collect things together unless you have to. You've got an answer, you've simplified it enough, don't overcomplicate it, that's your final answer. Excuse me. Let's have a look at another example. In example 23 here, we're being asked to differentiate 2x cos of x. This is a really common type of question where you use the product rule, and it's almost a little bit sneaky sometimes. Sometimes if you only have an x or a 2x in front of a function, it might not be obvious that you're using the product rule. But again, you can see that this is the product of two functions of x, right? 2x on its own, that is a function of x, and cos x on its own is a function of x. So this, if you were sort of not reading it carefully, you mightn't think that this is a product rule question, but it is. And so we're going to go through the same steps again. We're going to say, okay, well, if that's our original function, then the derivative will equal, write down the first thing, 2x, times the derivative of the second thing, which is, okay, derivative of cos x is negative sine of x, plus, put down the second thing, times the derivative of the first thing, and the derivative of 2x is just 2. Right, again, and then you neaten it up if you can. So we've got our first term there is negative 2x sine x plus 2 cos x. Okay, so a couple of quick examples there, but I hope that gives you an idea of how to apply the product rule. And in the next video, we're going to go through a few exam questions where we apply the product rule so you can see how those work as well. Good luck with your exercises, and as always, get in touch with your teacher if you need a hand with anything.